Algebra 2, Section 1.3, Solving Equations. Just as we review our order of operations this morning, and we take a look at this, we want to consider parentheses being first, exponents second, multiplying and dividing, notice, together in order from left to right. That is crucial to remember. And then finally, addition and subtraction together in order from left to right. So let's practice these together and just kind of walk through this as our warm-up practice for our first one. We have 3 times 8 squared plus 12 divided by 4. We're going to do the exponents first. So 8 squared is 64. Next, we're going to do our multiplying and dividing. And so we think to ourselves, what is 3 times 64? Well, you can do this in your head. 3 times 60 is 180, and 3 times 4 is 12. So if we add 180 and 12, we'll get 192. And we do our dividing. 12 divided by 4 is 3. So our answer, very simply, is 195. This is also a reminder that I would like you to work down on your paper and then box your answer. Our next problem, we have 2 sets of parentheses. We have 40 plus 24, which is 64, divided by 8 minus 2 cubed plus 1. 2 cubed is 8, 8 plus 1 is 9. And so we have 64 divided by 8, which is 8, minus 9. So that's going to give us an answer of -1. Our final one has variables here. So the first thing we're going to do is we're going to deal with the parentheses, being the fact that we have to distribute the negative sign into our problem. So the minus sign is going to go into both of our parts. And as you can see, we have that minus sign distributed there and our minus sign distributed there. We now combine our like terms. 3y squared and -2y squared is 1y squared. And 8 minus 12 is -4. As a sidebar, just as a reminder, this factors to y plus 2 and y minus 2. But our true answer is y squared minus 4. Maybe you remembered that that's how you factor it, though. If you did, good for you. Let's move in now to our material for today. Hopefully that was a good review in order of operations. Our objective today is to understand how to solve an equation. And the solution of an equation is the number that makes the equation, very simply, true. What does it mean to be true? It means when you plug in the number, you get 5 equals 5 or 7 equals 7 or something like that. So when we're solving equations, as a reminder, we're going to work the problem backwards in reverse order of PEMDAS. So we're going to do adding and subtracting first, followed by multiplying and dividing, followed by exponents, followed by parentheses. And there you can see PEMDAS is in reverse order. So as we're working this, we're going to combine like terms first by gathering the like terms together. I have 7x on the left, I have 2x on the right. As a reminder, because the 7x is larger, I'm going to move the smaller variable to the larger one by subtracting 2x from both sides. I subtract because it's the opposite of a positive 2x. That gives me 5x plus 3 equals -12. And now I'm going to undo this problem by getting rid of the plus 3 first, and to do that I'm going to subtract 3 from both sides. That now gives me 5x equals -15. You'll notice I'm working down on my paper and not adding a -3 to each of the sides of the equation, and that's how I'd like you to continue to do that. Our final step is to eliminate the 5 in front of the x, which is connected with multiplication. So to do that, we're going to undo the multiplication by using division. That gives us a final answer of x equals -3. I wonder if this makes the problem true. So let's plug this back in. 7 parentheses plus 3 equals 2 parentheses minus 12. Our answer was -3, and so we're going to evaluate for -3. And if this truly is a solution to the problem, we should get a true statement at the end. Well, -21 plus 3 is -18. -6 plus minus 12 is -18. So it checks, and that means the equation is true. Let's look at our next one. Our next one presents us with an issue of distributing first. So 6n minus 24 equals 3n. I'm going to move the 24 over to the right, That gives me 6n equals 3n plus 24. I do this because it doesn't matter whether you move the numbers first or the variables first. I'm now going to subtract 3n from both sides. 3n equals 24 and divide by 3 to get n equals 8. Let's check this one orally, shall we? 8 minus 4 is 4. 6 times 4 is 24. 3 times 8 is 24. And so it does check. Let's look at our next one. Let's distribute first. 4 times both the m and the 9 gives us 4m plus 36. And the negative 3 times both gives us negative 3m plus 12. Be careful that you remember that's a plus 12. This time I'm going to choose to move my variables first for no other reason than it's different than the last one. Once again, whether you move variables first or numbers first, it doesn't matter. So that gives me 7m plus 36 equals 12. Move my 36 over. Can you think of what 12 minus 36 is faster than I can write it? Hopefully you did, and you got negative 24. Interesting that in this case, when we divide both sides by 7, our answer is not necessarily a nice, neat integer, but negative 24 over 7. So we have to realize that not all the time are we going to get an answer that's a nice, neat integer like we did on A and B. Don't be worried when you get a fraction for an answer. Let's look at the next page. Sometimes when solving equations with no numbers, we're going to have to expand, combine like terms, or solve for variables, once again using PEMDAS in reverse order. When working with variables, you may not have a denominator that would give you a value of what? What cannot ever be in the denominator? Well, I hope you would pick up on that, and I'm going to blow this up so we can write it with emphasis. You can never have 0 in the denominator. So we have to think what kind of values would give us 0 in the denominator, and we have to very specifically note those values in our answer as restrictions. On our next two problems, we're going to be solving for the variable x. So how is b connected to x? Well, it's connected with multiplication. So I'm going to eliminate the b by dividing both sides by b. That gives me x equals c over b. Now, do you see our denominator here? Well, remember, our restriction also says b cannot equal 0. So our answer is both the equation and the restriction. Let's look over here at our second problem. First, we want to isolate the term ax by getting rid of the minus b. So to do that, we're going to add b to both sides. That gives me ax equals c plus b, or b plus c. I'm going to write it that way just because it's alphabetical. And with addition, remembering from yesterday, the commutative property allows us to do that. Our final step would be to divide both sides by a, and that gives us x equals b plus c divided by a. We have a variable in the denominator, so think to yourself, what value would make that equal to 0? Well, very simply, a cannot be 0, because if it was, the problem would not be able to be solved. So remember, on these problems, you're going to have to both solve and give the restrictions. Let's look down at our next problem on example 3. As we solve these following equations for x and we find c now, we first might have to combine like terms. We have ax plus bx. We're going to have to remember back to last year, how are we going to isolate that x? I'm going to give you a little hint here. It's 9 letters. It has an A there, it has an O there, and it has an I there. Don't know if you can think of that word, how you're going to get that x by itself, but that word, and I'm sure you're guessing it now, is factoring. So let's factor out the x. Take the x out front. That leaves us a plus b on the inside equals c. How is the a plus b connected to the x with multiplication? So to get rid of it, we're going to divide both sides by a plus b. That gives us x equals c over a plus b as a solution. I like this problem because it gives us a new chance to think about our restrictions. A plus b cannot equal 0. Or if you want to think about it this way, a cannot equal the opposite of b. So our equation is there, and our restriction is there. Okay, we're moving on here. Let's look down at example 4 and finish this up. As we solve this equation for x, we do throw a number in there, and we're going to have to try to figure out how to isolate the x. So, do you think you want to multiply by a first or subtract 8? I'd subtract 8 because that's the addition subtraction. And remember, PEMDAS in reverse. So that gives me x over a equals b minus 8. To get rid of the dividing by a, we're going to multiply both sides by a. Because you multiply, and that's the opposite of division. Notice on the right side I used parentheses. The a's on the left are going to cancel, leaving me x equals ab minus 8a, or x equals a times b minus 8. Now, both of these could be written as our answers, and it doesn't matter which one you have, so long as you have one of both of them. I need you to look at the original problem as well as the answer. There's no variables in our denominators in our answer. However, the original problem has a value of a in the denominator. So my restriction says a cannot be equal to 0. Let's look back and see if our other original problems had any variables in the denominator. None on example 3, none on example 2. So in this case, we're okay. But be aware on this last example 4 that if there's an a in the problem or in the answer in the denominator, we have to consider that as a restriction. Let's take a look at some real-world applications. Here on the right, you see I have a box with 6 squares. The sides are in a ratio of 3 to 2. Well, I don't know how big those are. It's not exactly 3 inches or 3 feet, so I'm going to call it the ratio 3x to 2x. Well, if I label all 4 of my sides as 3x and 2x, then the question is, what's the value of x? So let's add those up. 3x plus 2x plus 3x plus 2x, and that equals my perimeter of 110 feet. Well, that's 10x equals 110 feet. To divide this, I'm sure at this point you can very easily see you divide both sides by 10, which gives you a value of x equals 11. Is the answer 11? No. The question is, what is the length of each side? So we're going to take that value and plug it back in. And we're going to say 3 times 11 is 33 feet. And then we're going to say 2 times 11 is 22 feet. It's very important that we answer the question as we work through this. Is the ratio of these two 3 to 2? You bet it is. Because if you took 33 and divided it by 22, that would reduce to 3 over 2, which is your ratio. Whenever you get a problem that has ratios in it, make x's in there, set up an equation, solve for x, and then plug it back in to get your values. So let's draw our triangle here. 3, 4, 5. I'm going to call this side my 3x side, this side my 4x side, and this side looks to be my longest as my 5x side. I know it's maybe not drawn completely to scale, but we still can try to work through this. So I've got 3x plus 4x plus 5x as my equation. That gives me 12x. And we're going to set that 12x equal to 30. We divide both sides by 12, and we reduce that. 30 divided by 12 is 2.5. So my value of x is 2.5. The question is, what is the length of the longest side? Well, I think you see that's 5x. So 5 times 2.5 is 12.5 centimeters. And that's the length of your longest side. Hope that makes sense. Our homework is at the bottom and should be fairly straightforward. Have a great day.